Hi, I'm Drew, Application Engineer with SKF. In this video, we'll be covering data analysis and reporting with your Baker AWA. The newer information in this window will be at the top, and in this lower window will be on the left side. So let's go through the parameters. We have the temperature at which the stator was at the time of test that was entered. Even if you enter in degrees Fahrenheit, the value is saved as a degrees Celsius measurement. The next section is the resistance status. The first three rows are reserved for resistance testing with the high voltage leads, which is far less accurate. If you tested the low voltage leads, as recommended, your values will be included here. First for lead 1 to 2, and 2 to 3, and then 3 to 1. The measured value will be on the left, and then the temperature corrected value will be on the right. The max delta R, or resistive imbalance percentage, is listed next. And then the individual calculated coil values are listed last, the last three values. Again, the as measured and temperature corrected values. Then we have the megohm status, so the voltage at which the megohm test was performed, the leakage current at the end of 1 minute, the calculated resistance, which is in megohms, is given next. This is simply the voltage divided by the leakage current. Remember that the current is in microamps. And then finally the temperature corrected value is below that. And the next section would be the PI or DA. If it passes, of course, we'll have the green pass. If there was a failure, it would be red or yellow for caution, with the additional information listed in the block. So the PI, again, is the same voltage, continued. The ratio of leakage current from 30 seconds to 3 minutes will be the DA ratio, and the PI ratio is the current from 1 minute divided by 10 minutes. We'd like to see these values greater than 2 ideally, but in the field it could be much lower. The next section is the value for high pot testing. If you did a conventional high pot test, this will be the only information you have for your high pot. Step voltage testing will also have a graph later. This is the test voltage that we achieved, the final test voltage we achieved, the leakage current at the end of the final step, or the 1 minute high pot, the calculated resistance, and the temperature corrected value. And then finally the numbers for surge testing, the test voltage achieved for each lead, the maximum pulse-to-pulse error area ratio percentage for each phase, lead 1, lead 2, and lead 3, and then the line-to-line EAR, if you had that percentage turned on, would be listed here. Now to drill into the individual graphs for each of these tests, we have to click on the next tabs. Let's go through the surge test first. Here we see the surge waveforms is collected. We can enlarge them, and we can also look at them on their own or overlay them. Now in this case we're seeing the evidence of rotor influence, and the lines don't line up. We can also look at the nested view, how the waveforms grow within each other. This is sometimes indicative of stability as well. On the main panel, in addition to the waveform graph, we also have the peak voltages, the individual PPEAR, max PPEAR for each individual phase, and the line-to-line EAR percentages. We can click on the EAR graph to see the pulse-to-pulse EAR graph over the entire test. Of course, for this we want to see a nice, relatively flat curve. Okay, here next is the PI. Here we see the PI graph. The red represents the leakage current over time. The black is the calculated resistance over time. And you can manipulate the graphs to see minute or second data for each of those parameters. A table is also included to show the current at each of these time markers. 15 seconds up to 1 minute, 30 seconds up to 3 minutes, and then 1 minute for each additional minute up to 10. The last tab is the step voltage tab, where we can see the voltage relative to the current on an XY plot. A table is included below, We can also click on current and voltage versus time to see the actual current graph, voltage graph in blue, current in red, and the green lines and triangles represent the leakage current at the end of each step. In this case, we're looking for a linear relationship here. All right. We can also look at the trending information. So we have the trending tab. We can look at the different values that are available over time. Of course, we need multiple data points. So from the trending tab, we can see values as they relate over time from test to test for resistive imbalance, the actual resistance values, megohm trend, the PI trend, if you've done PI testing, of course, and the high pot trend. You have an option to include current or not include current, include megohms corrected or not corrected. If you've entered humidity, this is where you would check the box to include that in the data, and then you can turn the markers on and off as well. Oops. Okay. The trending tab will allow you to compare data points from time to time and see how your values are changing. We have several parameters that we can trend. You can include the calculated resistance as well, whether it's corrected or not corrected. The trending tab is provided to allow for comparison of data points from time to time, from testing point to testing point, and to see how things are changing. You can select from a variety of measurements to compare: resistance, high pot, PI, megohm, and there's various features that you can turn on and off to include or not include in your plot. You can select specific dates by holding down Control and highlighting the fields or the tests that you'd like to include. You can reset the graph, of course, and also select the print option for just the graph or a graph with an associated table. To generate a report, we simply click the print icon or click File, Print to bring up the report generator. There are several methods to select tests to include in the report. You can either select the current motor test result that's selected here, or you can select multiple tests by using a date range or specific locations and asset numbers from your machine tree. You can also select just tests that have failed or passed, specific to all of the tests or down to one individual test. For this demonstration, I'll select current motor test result. So we can include a report title. We'll include a title called Demo Report. You can check this box to include the tester information, that's the serial number, calibration information. And then there's a variety of different templates that you can select to include in your report. You can output your report to RTF, MHTML, directly to a printer, a comma delimited text file, and if you're on a desktop with Word installed, you can also select MS Word. I recommend report generation be conducted on a desktop as it's more efficient that way. You simply click Create Report, and a report will be generated.